Hello guys, let's solve Geeks for Geeks daily challenge. Largest square formed in a matrix. Given a binary matrix of size n and m, find the maximum length of side of a square submatrix with all ones. Okay. In the first case, the largest submatrix of the formed of size 3. In the second test case, the value is 2. In the test case 0. Okay. Given n and m will lies in between 1 to 500. Okay. The brute force approach is what we can do for every index in the matrix we can find what is the possible length of the submatrix which is formed with all ones. The time complexity of that approach will lead to n power 4. Now what we can do is for optimized approach, we can simply take for each index what will be the maximum submatrix we can form. Like for this one the maximum length will be a 1. For this one the maximum length will be 1. For this one the maximum length will be 1. But for this cell the maximum length will be 2 because the both the adjacents are 1 and then the left diagonals is also 1. So we can simply mark here as 2. The same for this one. Both the adjacents are maximum are 1 and then the diagonals also 1. So we can mark as 2. Here we can mark as 1. Here we can mark as 2. But for this one, both the adjacents are 2. The 2 are indicating that the maximum submatrix we can form of length 2. Here the 2 will indicate that the maximum submatrix we can form of length 2. Here the 2 will indicate that the maximum submatrix we can form that is a length 2. So we can take the minimum of these 3 and then add 1 to it. So 3. So we can simply make it as let's change this at m and n. Let's mark as d. Let's create a new array. Let's array. First we can fill the left and first row and then the first column. Zero through that's it, yes. Max side that was equal to initially 0. What we can do is if mat of 0 I that was equal to 1, we can simply make max side that was equal to 1 plus. The same for column. What we can do is for ith column and then for 0 then we simply make it as max row. Now we can start from first row and then the first column. First column. The first check is if my dp of if my matrix of if my current cell is 1, we need to take the maximum of both the adjacents and then let's say example, we need to take the minimum of both the adjacents and then the minimum of a diagonal. Okay, here the minimum will be a 0, so we can simply add a 1 to it. So here 1 will come, here also the minimum will be a 0, so add 1 to it. Here the minimum will be a 0, add 1 to it. For here the minimum will be 1, so we can add 1 plus the minimum value. Okay, here the 2 will come. For this cell, the minimum will be, the adjacent values are 1, 2, the minimum will be a 1, so we can add 1 plus the minimum value. Also, okay, the min adjacent value that was equal to the minimum of dp of I minus 1 and j value, and then the dp of j minus 1th value. Again we need to take min adjacent, that also is equal to method minimum of min adjacent comma of dp of I minus 1 and then j minus 1 value. Okay, and then what we can do is dp of I j, that was equal to 1 plus min adjacent value. Okay, after that we need to take max psi, that was equal to maximum of max psi, or else dp of I j. Newton max psi. We messed up here. Yeah, one more, the dp. Yeah, the value will be 2. Let's take one more example. Let's take this as example. The value will be 615 011 01 11010 01110. Yeah, 41 and 0151 6 ones. Yeah, our answer will be right. We can go. Yes.